Hi everyone! Today our group will introduce you the basic operations for the transformers as well as the step up and step down equations. So what is a transformer? A transformer is a two-port device capable of transforming an AC input voltage into a higher or lower AC output voltage. Transformers are sometimes classified as step up or step down, and we'll talk about that later in the video. The voltage conversion mechanism relates on the changing magnetic field generated by a changing current. The transformer works according to Faraday's law of induction, as changing magnetic flux will induce voltage. And here we draw a diagram for the transformer. As you can see, here's the primary coil, and we notice this turns as the numbers of the turns as NP. And the right-hand side, here's the secondary coil, and we notice this as N sub S. As the turns, a number turns of this coil. And in the middle part is the magnetic flux, which is also an iron core. And here's the symbol of the iron core transformer demonstrated in the circuit diagram. And how this works? Well, we will apply an AC voltage to the primary coil of the transformer, and alternating magnetic flux emanates from the primary coil and propagate through the iron core and pass it through the secondary coil. And the different numbers of the turns of the coils between the primary and secondary will determine if the output voltage will increase or decrease.
A step-up transformer will have an output AC voltage that is higher than the input voltage. We can calculate the input and output voltage using an equation called the transformer voltage ratio. This equation shows that the voltage is proportional to the ratio of coil turns. Here we have Vp, which is the primary voltage, the input voltage, over Np, which is the number of turns in the primary coil, is equal to Vs, which is the secondary voltage or the output voltage, over Ns, which is the number of turns in the secondary coil. We have the same equation just kind of rewritten here in a different form. So, since the voltage is proportional to the ratio of coil turns, if the number of turns in the primary coil is smaller than the number of turns in the secondary coil, the secondary voltage will be larger than the primary voltage, i.e. stepped up. So we have an example here of a transformer with 200 turns in the primary coil and 1200 turns in the secondary coil. If we give it an input AC voltage of 120 VAC, plug it into our equation, we find that our output voltage, our secondary voltage, is equal to 720 VAC. Since our output voltage is increased from our input voltage, this is a step-up transformer. A step-down transformer is essentially the opposite of a step-up transformer. For a transformer with more turns in the primary coil than in the secondary coil, the secondary voltage will be smaller than the primary voltage, i.e. stepped down. So we use this same equation here to calculate a step-down transformer as well. We have another example here of a step-down transformer, and in this one, we've essentially flipped the ratio of our turns in our coils. Here, in our primary coil, we have 1200 turns, and in our secondary coil, we have 200 turns. If we give it the same input voltage of 120 VAC, use our equation, our output voltage will be 20 VAC, meaning that this is a step-down transformer because our output voltage is decreased from our input voltage. There you have it, an introduction to transformers, an incredible electronics component. After watching this video, you should be able to determine whether a transformer is step up or step down, which will help you determine the right kind of transformer to use in your circuit. Thank you so much for watching our video.